Okay, good morning, guys. Today is March 21st, second day of spring, and it's supposed to be 60-some degrees outside. Go ahead and get our journal first, and then we'll kind of go over what we're going to be doing today. Part of the day, I'm going to go through kind of a quick review over the skull bones, give you some opportunity to look over the bones of the skull, kind of talk about that a little bit. Then we will finish the axial skeleton bones and get the appendicular bones. So today is kind of finish up the rest of the bones and make sure we know where they are located. So go ahead and get journal, and then we'll go from there. If you need to pause the video at any time, go ahead and do so, and then we can continue. Okay, a couple things real quick. At this point, we've gone through the bones of the skull. We'll do a quick review over the vertebral column. The first 7 are called, that's right, the first 7 are called the cervical vertebrae. The first one, C1, is called the atlas. C2 is called the axis. Usually if I pause, somebody can jump in there and answer. Good review. Maybe more than just the second row or first row. Somebody from the back even. If I look at an individual vertebrae, again, you don't necessarily need to know all these terms, but it's interesting, especially for the lumbar. This is a picture of a whale lumbar vertebrae. The body is huge. Okay, so that kind of gives you some sense of the scale of a whale. But that's just kind of an interesting picture. So you have the, let me go to a different picture real quick. The first 7 are the cervical vertebrae, with C1 and C2, you should know the names of those. Thoracic are the next 12. The next 5 are the lumbar, with the wings. The thoracic ones have this really long process which kind of overlaps the next one. But that's basically what you should know on those. And then you get down to the 4th region, which is the sacral or the sacrum. Once they've fused, those start off as 5. 1, 2, 3, 4. And I missed one someplace. My numbers aren't quite right. But there should be 5. We'll pretend that's 5. And those 5 fuse together to form one sacrum. And then the very last little piece are the coccygeal, coccyx, which fuse together to form the coccyx or tailbone. So technically one bone, but it started off as more. I found this picture. I thought some of you might be interested in seeing it. So here's a giraffe. They're a mammal just like we are. And if you count 1, 2, 3, 4, 5, 6, 7. The atlas, axis, C3, 4, 5, 6, 7. They have 7 vertebrae in their neck just like we do. The difference is their vertebrae are about a hand and a half, maybe even 2 hands long. Okay, so each of these is probably over a foot. For sure. For sure they'd be over a foot. Okay, so that's how they get such a long neck. Somebody asked me in a zoology class if they have more bones than we do. They actually have the same in their neck. They're just each one a lot bigger. Interesting question. So I thought that I would share that with you. Today, quick review. Bones of the skull. Now normally, again, if I was there, I would be doing this as a formative quiz, but this will give you an idea if you know the bones or not. I will go ahead and tell you that on Tuesday, there will be a skull practical. You should be familiar and be able to identify all 22 bones of the skull. I will have stickers or pins at different points of skulls, mostly human, but I will definitely be using some of the animals as well. So part of today is going to be allowing you some time to review those on your own with the animal skulls. So that'll be Tuesday. So make sure, I'll show you a couple resources on Moodle that will be very, very, very useful. I already told Kate about these, but some of you may not be aware of them. The bone that makes up the top of the eye socket is the frontal bone, and if you notice, it goes back to this suture, but it's covering the frontal lobe. So I think that one's pretty easy, straightforward. This bone is parietal, 2 bones. Technically, you can't see it, but there'd be a division there. They're covering most of the bulk of the skull. This is a view from the side, that's a view from the back. This bone, occipital. There's a really large hole right there. What's the name of the hole? Foramen magnum. Large opening. Okay, that's where the brainstem would be. Interesting view. Very distinctive shape, especially from either the back or from the top. If we were looking from the top down, we would see a similar looking shape. All of the cranial bones connect to this one, otherwise called the sphenoid. The sphenoid, all the bones, sometimes called the keystone. All the bones are going to connect to that one. This one has a smaller hole right there called the external auditory meatus. Yes, you might want to be familiar with that term. External auditory meatus. So this is your temporal bone. Part of it also makes up your cheekbone arch. Okay, so it's connecting with a facial bone called the zygomatic there in the front. External auditory meatus, those are cranial bones. The only other bone you can't really see, I didn't have a good picture of this one, is the ethmoid. The ethmoid makes up basically the top part of your nasal cavity, and there's a couple conchae. If you don't know how to spell that, C-O-N-C-H-A-E, but the conchae are these kind of scroll-looking extensions of the bone. But that's, again, top of the nasal cavity. It makes just a little portion of the cranium, but your olfactory bulbs, curiously enough, the olfactory bulbs would be sitting right on top of the ethmoid. Okay, so that's a way to kind of figure out where those are located. Okay, so that's a quick review over the cranial bones. To review the facial bones, I wanted to show you a couple resources on Moodle. These are really good places to go to study for your skull practical. Right here. Okay, there's a couple websites. There's real skulls that you can look at. And there's a really nice skull quiz here, so that's the one I'm going to show you, kind of walk you through, just to save time. I'm not going to go through the whole thing, but I'll allow you to do that as much as you want. So if I click on that, it's going to take me to different views. You can do anterior views, orbital views, lateral views, cranial floor views, a number of different places. For example, right now I've got a pin in a bone, and I'm going to have to go over to the keyboard, so you may lose my voice. Let's do anterior view. Hopefully you're thinking maxilla, and you can check your answer. Ooh, that's a tricky one. The back, and check your answer. That one's an easy one. Check your answer. So it's going to go through all the different ways. Just to show you, you could switch to real bone or a drawing. You can even add color or remove color. So there's lots of different possibilities there. I was going to say, if you want to go to a different view, this is like if we zoom in on just the orbit, there's lots of bones there. The lateral view, the inside view, the floor view, okay, inferior. So there's lots of different views that you can go to on that. And all of those are going to be equally beneficial. This one's pretty good too. On this one, it basically will point to something once you hit start, and it will, every 5 seconds, go through a bone. So again, I would encourage all of you to utilize these resources. These are awesome, awesome study tools. There is no reason for you not to get a good grade on Tuesday on your skull practical if you practice. If you practice, there's nothing I can surprise you with. Okay? But if it's anywhere on the skull, you should be able to identify the bone based on the way I've labeled it. Okay? So again, there's several resources there. It goes through facial bones, it goes through cranial bones, it goes through all of the structures you will be required to know for Tuesday. Okay. Hopefully that's of assistance. Questions at this point? You might want to, if you do have a question, wanted to give you an opportunity, if I can get to it. Right here. If there's a question, you can leave it here, and I'll try to respond to it. And I know it says Chapter 7, but it should be Chapter 6 and Chapter 7 together. Okay, but that'll give you an opportunity to ask a question if you have a question. All right. At this point, you're going to get a skeleton diagram. Actually, hang on to that. Hold off on that idea. We'll do a couple real quick notes, and then we'll do that. Okay? So, whatever you've been taking notes with, get those out, and we'll be ready to go. Let me skip through. I think we got all that. 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 Okay. I think that's as far as we got. Sinuses. Some of us are having trouble with sinuses and some of us don't. The definition of a sinus is a space inside of bone. It's an actual physical cavity within the bone And these show up on your diagram, your colored skull diagram. But they're actual physical spaces. You've got several of them. It's contested what their actual importance is. There's a couple different things we can come up with. Part of it, they're lined with mucus. And part of that is going to be to trap organisms, dust, mold, other materials that could be breathed in. And the idea is if we are breathing in these materials, we want them trapped before they go on to something else. Okay, they could go into further infection. So your sinuses trap those materials, and then when you blow your nose or they're continuously draining down your throat, then we're getting rid of those particles, viruses, bacteria, etc. The other importance is it helps to lighten our skull. We've already got 3 pounds of gray matter up there, gray and white. Throw on some more bone, which is dense, and that's a really heavy structure to try to balance on our spinal column. So if we have sinuses, then you've got some hollow spaces, and that allows for a lighter skull. And really the last importance is maybe it helps to reverberate sound. As you talk, some of the sound waves travel up through your bone tissue and reverberate within your sinuses. So many singers will talk about their head voice. Their head voice, or sometimes called a falsetto, is basically sound going through your sinuses. It's going through the nasal passageways. It's a higher voice. It's sometimes called your head voice. All of us have noticed when we're sick or our nose is congested, we don't quite sound the same because our voice doesn't reverberate through our sinuses like it normally would. So there's a couple different things. Some miscellaneous bones of the skull. We already have the malleus, the incus, the stapes. These are technically part of the skull. The auditory ossicles. Those are the 3 tiniest bones of the skull. And then the hyoid we were talking about last time. This is an unusual bone because it's not connected to any other bone. It's suspended above your windpipe by ligaments. And this is also what your tongue attaches to at the base. So your tongue's a muscle, it has to be attached to a bone. So this is going to kind of float up and down some, but it's going to give structural support. The only reason we kind of mention it is during strangulation or hangings, this bone is invariably broken. And so if a forensic scientist finds or a coroner finds a broken hyoid, it's usually indication of strangulation. But it's hard to feel, but it'd be up above your larynx and behind your mandible. So it's up in that region. Finish up our axial skeleton. So the first thing we had was the vertebral column. The second thing we had was the skull. The third thing is our sternum. Sternum has 3 parts. The first part's called the manubrium. The second part's called the body. And the third part is called the xiphoid process. It's pronounced like a Z, like xi, but it's actually spelled with an X, just to make it complicated. The 3 parts usually are fused together. It's not 3 separate bones, they're just 3 parts. Especially in an older adult, you wouldn't even be able to tell the difference. There's all 3 together. The notable part is this little xiphoid process piece, especially when performing CPR. When we're doing CPR, you're instructed to do about 2 finger widths up. So you're basically putting the palm of your hand, okay, the bulk of your weight on the body part. If you were to put your weight on this part, doing your chest percussions, you could break off the xiphoid process and impale a lung. That would kind of defeat the whole purpose of CPR. So that's why they tell you to do 2 to 3 finger widths up from the bottom of the rib cage so that you're not on the xiphoid process. Just kind of an interesting little side note. Below the sternum or around the sternum, we have our ribs. We have 24 ribs, 12 pair. Males don't have one less than females. I know the creation account, evidently God put it back, or however you want to explain that. But the basic idea is male and female have the same number. There's 12 pairs, one for every vertebra, every thoracic vertebrae. There are 3 types of ribs, though. It didn't work. I was hoping it'd work. Okay. There are 3 types of ribs. The first 7, see if we can count them. 1, 2, 3, 4, 5, 6, 7. The first 7 are called true ribs because the way true ribs work, they go from a thoracic vertebrae directly to a part of the sternum. So there's 6 and there's 7 on both sides. So those are the true ribs. False ribs are 8, 9, 10. And if you notice, those 3 connect to each other first, and then they connect basically to the 7th rib. Okay, but the 8, 9, 10 false ribs, they're not like true false multiple choice idea, but they're false in the fact that they connect to each other before they connect to the sternum. So here's 8, 9, 10 on that side. They connect to each other first and then to the sternum. The most odd ones are the last 2 pairs, 11 and 12. These are the floating ribs, and the reason they're odd is they don't even connect to the sternum at all. They're only connected in the back, so they're actually pretty easy to break. And what I would encourage you to do, it feels kind of funny, but if you take a deep breath in, kind of suck your stomach in, feel the ends of your rib cage, work your way down about halfway, and ouch! You'll feel the ends of your floating ribs. Take a deep breath in, feel them, ouch, and then a little bit farther down, ouch. Okay, so those are the floating ribs, and what you would find is right about here and here are your kidneys. So your kidneys are slightly protected by your floating ribs, but they're not connected in the front, so they're not offering that much protection. Okay, at this point we're going to pause. Hand out your skeleton diagram, and then we'll pick back up. Okay, we're going to go through these pretty fast. You can pause it whenever you need to, because I'm going to try to go through it really quick. So if you want to color code these, great. If you don't want to color code it, fine. Okay, but you should be able to label the first, I don't know, 10, 11, 12. Well, there's some of these that you could already go ahead and label, and I'll go over those perhaps on Tuesday after your practical, but I'll go over the bones that we have not covered yet, okay? All right, so appendicular skeleton, very briefly, are the bones of the arms, legs, and girdles. A girdle is the point of attachment, so here's a girdle, called the pectoral, and here's a pelvic girdle. These are the points of attachment for our arms and legs. If axial was protection, appendicular is for movement. So we're going to kind of focus on the upper extremities first and then kind of work our way down, is kind of the way that makes most sense to me. The pectoral girdle is first. This is made up of 2 bones. And I'm putting the total number on the side because we're bilaterally symmetric. We're going to have one on one side, one on the other side. The first bone that we encounter is the clavicle, or otherwise known as your collarbone. Your shoulder blade is called your scapula. Okay, so again, on your diagram, if you want to follow along, number 13 is your clavicle. Number 15 is your scapula. Okay, and you'll notice that the pectoral girdle is kind of sloppily put together. There's a lot of range of motion. Below the pectoral girdle, we have the actual appendage, our arm. Our arm is made up of 3 bones in each arm. Upper bone, the larger bone, is the humerus. This is number 20. Below the humerus, we have 2 forearm bones, the ulna and the radius. Now the way to tell the difference is the radius is always thumb side. The radius is always thumb side. Okay? The ulna is pinky side. And if you can come up with a way to do that, pinky side. Okay? A pink ulna, I don't know, whatever way you want to think about it. Radical radius. But the basic way to remember it, so 21 is going to be the radius, 22 is going to be the ulna. But if you rotate your forearm from side to side, kind of turn your palm up and then turn your palm down, you'll notice your thumb bone moves around the other. And I would encourage one of you or 2 of you to go over to one of the skeletons and demonstrate that on the skeleton, so you can see that one bone rotates around the other. And if you're super, super crazy careful, you can get one of the arms out of the skeleton or show it on the real skeleton, as long as you guys are really, really, really careful. Okay. Then we get down to the hand. The hand has tons of bones. Okay, especially because you figure how many we've got in each one and then double that. So these are the total numbers. 2 rows of 4 in each hand. So in each hand we've got 8 wrist bones. This is 23. Is the carpals. The metacarpals make up your palm. Number 24 are the metacarpals. The palm of your hand are your metas. Meta means beyond. And then phalanges are your fingers. You have 3 in each finger. If you take a look at your finger and bend it, you've got 3 bones in each finger. But your thumb only has 2. So technically, the thumb is not a finger, if you want to argue that. The thumb is given a special name. It's called the pollex. P-O-L-L-E-X. It's not technically a finger, but it does have 2 phalanges. Okay, so that's the arm. Switch to the legs and lower extremities. At the lower extremities, we have the pelvic girdle. Pelvic girdle is made up of 2 coxal bones. Coxal bone is basically a hip bone that fuse over time. Okay, so we've got 2 coxal bones. Eventually they fuse together to form the pelvic girdle. Each of these was 3 bones, called the ilium, the ischium, and the pubis. The ilium, the ischium, and pubis bones. And to notice this, 27 is the ilium. 30 is the pubis. The pubis bone is in front, kind of creates this arch in the front of the pelvis. And then 31 is the ischium, which makes up basically the part you're sitting on. Okay, so again, the ilium forms this crest. It's the biggest section, it's 27. 30 is the pubis, 31 is the ischium. If you notice on the fake skeleton or the real one, at the very front, between the 2 pubis bones, there is a piece of cartilage. Fiber cartilage, we call it the pubic symphysis, and this is what's going to hold the 2 pieces, the 2 coxal bones together in the front. Taking a look at the leg. If you look at 32, 32s are femur, one of the longest, strongest bones of the body. 33 is the patella, our kneecap. 34 is the tibia, our shin. 35 is our fibula, which is the smaller of the 2 leg bones. And then we'll get to the foot. Shin splints, if for any of you runners, cross country or track, shin splints is basically the result of too much pulling on the tibia. That's where your quadriceps muscle attaches, right below the patella. And when you move your leg repetitively over and over and over and over, there can be inflammation on what's called the pericardium. But that's for another day. If we take a look at the foot, just the janitor going across the hallway. If you look at the foot, we've got a lot of different bones. The tarsals are going to be our ankle bones. And if you notice on your diagram, there are 2 specific tarsals. 36 is the talus, and 37 is our calcaneus, or heel bone. I encourage you to go and take a look at one of the feet, one of the legs, and really take a good look at the ankle. The talus, the reason it's important, this is going to bear all of your weight initially, and then when you step onto the ball of your foot, the weight gets distributed across your foot. Calcaneus is just your heel bone. It's going to bear a lot of the weight as well after the talus distributes that weight toward the front and toward the back. So calcaneus is your heel bone. Talus is going to be right above the calcaneus. 38 are the other tarsals. Okay, so there's 7 tarsals in each foot. We're only going to know two of the 7. Metatarsals, you got 5 in each foot. This makes up kind of the sole of your foot. This is 39. And then we have the phalanges all over again. You've got 3 phalanges in each toe, with the exception of the big toe, which only has 2. And it's called the hallux. So the thumb is called the pollex. The big toe is called the hallux. So 39 should be your metatarsals, your phalanges are still 25. So your finger bones and your toe bones are, for practical purposes, the same. Now, if you're an anthropologist or you're doing some sort of fossilized remains, people who are experts in that sort of thing would be able to tell a pinky toe phalange from a pinky finger phalange, but that is well beyond what I would be able to do. Okay. Those are all the parts of the bones. So at this point, depending on how much time there is, I want to encourage you to take a look at the skulls, practice, practice, practice. Take a look at the real skeleton, take a look at the fake skeleton. Those are really the only two you have to work with. If you're careful, you can even get the cat skeleton down and take a look at that. You'll notice that those are the ones that we're going to be required. Those are going to be the ones we're going to have our practical with. So skull practical on Tuesday, and prepare for that. That's the main thing. All right. Good job, guys. We'll see you on Tuesday.